Thanks for that introduction. That was nice. Moral psychology I kind of grew up in moral psychology, and one thing I noticed the longer that I was in it is like no one stays. If you make progress in moral psychology, you never stay in moral psychology. Like you always realize that's like this incredibly complicated thing that seems very interesting, but to make any progress at all, you have to understand like some much more basic component. And so you can just look at people who are historically moral psychologists and like they go, well, that guy just studies that thing. That guy just studies reinforcement learning now, or that guy just studies theory of mind now, and that guy studied causation now. It's kind of interesting. Anyway, I studied possibility in the end. So today, basically, I want to talk about this, I think, piece of mind that I've been like kind of fascinated by, which is our sense of like sort of the possibilities that are available in a given context. And I'm going to talk a lot about it, but I thought I'd start just by giving you a sense that you have this kind of thing. So one of the things I think is quite interesting about it is it feels like you have this immediate sense of sort of what's possible in a given situation. It feels like it's very flexible and dependent on the particular context that you're in, but somehow at the same time it feels kind of effortless to have. So here's an example just to give you the intuition. Here's a little scenario. So Daniel's the ring bearer at his sister's wedding. 10 minutes into the ceremony, he reaches into his pocket, but the ring isn't there. He realizes he left it on the seat next to him in the taxi. So Daniel decides to blame it on the maid of honor. Did Daniel have to blame it on the maid of honor? And it feels like you can have this, upon being asked that question, you should have this immediate sense probably that no, he didn't have to. There should be this immediate intuition, no, he didn't have to do it. But to me, what's really interesting about that particular question is it's not a question about what he actually did. It's a question about whether or not there were alternative things he could have done that were probably better than the thing that he actually did. And it seems at least intuitively that you can answer that question without having thought of the specific alternative that would have been the better thing to do instead. I mean, maybe some of you did have that insight about one better thing, but it feels like in a lot of cases you can answer these kinds of questions about alternative possibilities without thinking of them explicitly. But all the alternatives that you were representing in some way or another had to be sort of relevant for this particular context. So it sounds like somehow it seems like we have this context-sensitive, implicit representation of sort of sets of alternative possibilities. That's what I want to study, and we'll see how far I've gotten in trying to make progress on that piece of our mind. Okay, yeah?
Just to set the stage,
Yeah.
I totally understand what you're getting at from the example. In that example, you'd have to know a lot more about what led up to the ring getting lost, like was the maid robbery in the taxi with him? And things like, what does he want out of the situation? Like, is he trying to avoid getting blamed, or does he prioritize the truth a great deal?
Yeah.
Are those part of?
So all of those things will be things that will, on my view, would influence the possibilities you're representing. They would be important factors if you had access to information. It feels like you can have these judgments even without that information. So maybe you're just relying on your priors over those things, or maybe there's some other way of doing it. Maybe you just can construct abstract situations that ignore a bunch of pieces of the world, on the fly. There are different ways to think about how you do it. Those would be relevant if you have access to them. I'm not going to assume you're resolving every relevant piece of the world. Yes. Yeah. And we'll talk at least a little bit at the end about one piece like that. Okay, so what we want to measure is the set of possibilities represented as available in a given context. I'm going to call that representation a representation of contextual modal space. Modality, if people aren't familiar with that term, actually my thesis was, one of my thesis advisors was Paul Bloom, and I told him that my dissertation title was going to be The Psychological Representation of Modality. And he said, this is the worst title I've ever heard. And he said, everyone will just think you misspelled morality. Like, what are you doing? I've tried to just ignore Paul and just keep using this word. Modality was really something that's talked a lot about by linguists and philosophers. But in this context, you can just think about it as sort of a way of talking about possibilities. So sometimes it gets used in various ways, but when you see modal, just think, I'm interested in possibility representations. Okay, so contextual modal space are representations of possibilities that are context sensitive in some way. I'm going to talk about one way I've had of measuring it, and we can see how far that can take us. And hopefully the sort of bigger agenda is once we can measure this thing or have some idea of how you're representing it, we can take that and do some work with it. So what I want to do is show that if you can measure that, what you can do is show a bunch of interesting features about it. Like, for instance, that the representations of possibilities seem to be constrained by what you think is normal in various ways. So not just descriptive normality like probability, but also normal in a more sort of prescriptive way, like what would be good to do. I want to show that those representations are recruited in high-level cognition. So once you measure that, you can show that these high-level judgments, like whether or not someone should be blamed or had to do something, like had to blame it on the maid of honor, recruit this kind of representation. And I think, interestingly, you can show that that same representation can be used to predict a bunch of different high-level judgments. So it's sort of general purpose in the sense that the same representation I think you can use to predict, say, judgments of whether someone had to do something, judgments of causation, judgments of decision-making, judgments of moral responsibility, and so on. And then at the end, I want to talk a little bit about just showing evidence that they are flexible and context sensitive. They have this interesting feature. And that they're probably represented in sort of a distributional way or a heuristic way. They don't involve just thinking about token possibilities or online sampling of possibilities. Okay, so we'll see how much of I get through. But that's the agenda. Okay, so just start with just thinking about like how do you measure this idea that we have a representation of possibilities, and here's one way I've gone about it. So take a new situation like this. So Heinz's wife has recently fallen ill and needs an expensive medication that is not covered by her medical insurance. They don't have the money needed to purchase the expensive prescription, but they know that it is vital for her to have it if she's going to recover. So what could Heinz do? So we'd give participants scenarios like this, and then we just ask them to generate as many options as they could think of. And one way you can then now think about taking a look at that space, so this is one thing we've done, is you can take all the text descriptions and then you can cluster them just using sort of like, we take an embedding from a large language model, and then we just cluster on the embeddings for these text descriptions that people came up with of what the agent can do. And we just kind of group them. And then we can label a group just as like the point that's in the sort of the center of that group. So you'll notice there are a bunch of sort of intuitive groups in this Heinz case. So here, if you look at this purple group that is kind of flashing in and out is find insurance that will cover it. Here's a group that's kind of like steal stuff to get money, which is this group down here, sort of separate from everything else. Here's a get a second job. It's that sort of group. And so you can, let's see. Find RX discounts is kind of in there, small group. Okay. So you can get a sense for, and there's something that feels intuitive about this, that like this is the set of options that seem to be available, and you can kind of organize, this feels like, I didn't do any work, it was just data driven, but I kind of organized it in a way that feels somewhat intuitive, like closer options are closer together. Yeah.
Just out of curiosity, what LLM model is that?
This was a sentence BERT model that we used for this. You can use, we've done it in several different ways, including using bigger models, but we found that you can do it with relatively simple models. Okay, so now you can think not just about like, this is maybe an overview of the space, but we also had people sort of like sequentially generate options. So the idea was maybe you could also think about sort of how people are traveling through this space as they're generating options. So one way of doing that is just looking at sort of individual participant trajectories. So this is participant MYXTM. And you can look at sort of their trajectory through space. And it has a bunch of interesting features. So I think this is generation number one. So he could get a side job to make some extra income. He could contact the drug manufacturer to get a discount, see if a cheaper version becomes available. And then we're kind of down here in sort of insurance and generic version lands, similar drugs. And then there's this sort of big jump over here to do like a GoFundMe, essentially. And then a big jump back down here to see if there's free trials of medication. So the thought was, okay, if you think about sort of trajectories through this space, maybe you can get a sense for, how people did it, how people navigated that space, essentially. Here's another participant. You can see the variation in how people do this. It looks like they started, that's where they ended. I think they started in this cluster, and they spent a bunch of time in this cluster, which is sort of all about asking other people for help. And then they would take these kind of jumps away, like selling clothes or looking for a church that can support them. Okay, so that's one space, and sort of thinking about a little bit about how people navigate that space. If you think about sort of like what's a plausible model for how people are navigating it, one thing that we relied on a lot was this sort of other work on navigation or foraging in sort of natural environments. So the basic idea is if you're foraging for berries or mushrooms or something, what you should be doing is the pattern or trajectory that you take to that space is often called is well modeled by a Levy flight distribution. And the basic idea is, if you have a model of the environment and you're looking for sort of places to get food, you should be going to the patches you think are likely to kind of have food, and you should get the relevant food there. And then once you start sort of running out of good food there, you should move to a different place. That kind of structured exploration and sort of exploitation of an environment looks really different than if you were just randomly walking through it. So this is kind of a Brownian motion kind of way of thinking about how you might navigate a space. And those are going to have really different signatures. And so one idea that we had was that maybe we can use some of these differences in the signature to think about if people have this representation of sort of the space of possible options and they're navigating it in a sort of rational, structured way. So here's another example to give you a sense for it. So, Brad and some friends are hiking through the mountains in a Canadian wilderness. A couple of days into their hike, Brad realizes that they are lost. He knows that a rescue crew would arrive before long, but it's extremely cold and they don't have much food or water left. He also knows they're 5 miles from an inhabited town. If you consider what that sort of space looks like this. So options that people consider a lot are stay put where you are, that's that. Cluster, start to ration food for each person is a cluster kind of on the far right. Strangely, people really want to consider the possibility of drinking your urine if you need to. I got to advise you, don't do that. That actually increases dehydration. It's not a good survival but it is one of the options that people think of. You can see if your phone has signal, that's that kind of cluster. Okay, so that's the space, and then you can again think about how participants are going through that space. So here's one participant that goes from building a shelter to procuring water to getting a fire going to getting food, and then goes down here to hunker down, to huddle for heat, etc., and pops around. I don't know. There's another example of a different kind of trajectory through it. Now what we want to do is think about those features of different, sort of the different characteristics you should expect if people are foraging in a structured way. One way to look at it is just the number of step lengths. So if you think about sort of doing a levee flight, basically what you should do is you should go to a patch that you think has good food. You should forage around there and take little small steps, and then you should travel to another patch. And if you think about the distribution of step lengths, it should basically be a bunch of small steps and then a sort of long tail of differently long steps as you're jumping to different clusters. And then if you think about what a random walk would look like, it would look something more like this. It would just be, maybe it would shift wherever it is, but it'd just be a sort of a Gaussian distribution over step lengths as you're trying to just randomly walk around the environment. Yeah?
That's right. Clarification question. I'm not sure if you mentioned this before, but can you maybe walk me through one example with the task force in this experiment? So they read a story and then
you get a little context like that, and then you just say, we want you to generate as many options as you can. What could Brad do in this situation?
And they just list them one after another.
The way that we do it is when you think of an option, you press a space bar. A little text box appears, you write it in. And then when you think of another option, you press another space bar. So we can get response times between options. Yeah, and we wanted the response time not to be dependent on the length of the description, so that's why we do the space bar. Okay, so can we find evidence for that kind of sort of long-tailed distribution that would indicate sort of a structured exploration like a levee flight distribution would? One way to do it is to think about the step lengths as sort of semantic distances between options, since we're already sort of in embedding space land. If you look at things that way, here's sort of the 6 scenarios we used. And you can see, I think, relatively okay evidence for this. It looks like you get these longer tail distributions. They definitely don't look normally distributed for step length. Another way to do it is using response times, like I talked about. And that's a really standard way that people have thought about doing this. If you're doing foraging in other kind of like semantic memory tasks, like think of a zoo animal or something like that, you often use response time between options. If you look at the distributions, for those as a model of sort of distance between options, you see really nicely long-tailed distributions. If you wanted to think about this formally, basically you can ask, the details won't matter, but you can ask which parts of these distributions are well modeled by if you take log-log distributions, they should be sort of linear. And that would be like a good evidence. So anytime you see across these graphs, this is semantic distance and this is response time. Anytime you see the straight dotted line, that's cases where we found like sort of clear evidence that the best model of this was this long-tailed distribution. So sort of clear evidence that we find the pattern we're looking for. Okay, so sort of intro summary of this beginning part. It looks like, look, you do find evidence that people have a model of this environment, and they sort of explore it in a structured way. So if you just get them to generate a bunch of options, you can get a sense for what that space of options looks like. And it looks like they basically are doing a good path through that. They go basically to patches where they start, ones that they seem likely be fruitful to go to. They look around there for a while, and eventually they keep moving. So I want to talk about whether or not people can then, so maybe that's a way, say, of measuring contextual modal spaces or possibility spaces in a context. Are people using that when they make high-level judgments? So to go back to the sort of demo that I started with, this example of Daniel the ring bearer, whether or not Daniel had to blame it on the maid of honor, the thought was, okay, maybe we can do something similar. So we can take a context like this. We're going to predict their had-to judgment. The first step is going to be getting people to generate options in this kind of scenario. And then we want to think about sort of how the actual action that Daniel did, say like blaming on the maid of honor, is situated relative to the set of options that people generate in that scenario. And we can use that to predict their had-to judgment. So that's basically the approach we took. We went back to these kinds of contexts, like Daniel the ring bearer. We got participants to generate, in this case it was just 5 things that Daniel could do. We got a bunch of people to generate it. Here is one participant's set of answers. So they said you could borrow a ring, call the cab company, tell his sister about the problem, pretend he has it until the last minute, or he could fake a heart attack. We then, in this case, we gave them, part of what we're interested in is sort of the quality of the options that they were able to generate. So we gave them back the options that they generated, and we asked them 3 questions about them. We said, so one of the things you considered was tell his sister about the problem. How probable was it that Daniel would do that thing? How morally acceptable would it be for Daniel to do that thing? And how normal would it be for Daniel to do that thing? Those were, in other work, people have found probability, morality, and normality to be important features for possibility reasoning. We basically used them, took them from that literature and thought, this would be an okay estimate for how people were representing the quality of that option. If you want to think about how you can view that space, you can kind of view it within those 3 dimensions, something like this. So this is the sort of 3-dimensional representation of, in that context, the set of options that people generated. So up here in this sort of section is everything that was morally good, probable, and normal. And it's things like call the taxi company, explain the situation quietly, have someone else call the cab company. And you can see like the majority of things that people think of kind of like live in this area. They're kind of like, there's a sort of a denser cluster up there. The other thing is that you can think about the option generation. So if you look at just the first answers, those are kind of heavily situated up there. As you continue to think of like the second answers, the third answers, the fourth answers, and the fifth answers, you can see that they tend to shift down there. And if you focus really just on the last things that came to mind, let's see if I can get it. There are definitely more down here, and it's things like leave the wedding immediately and skip town, keep mute, steal someone else's ring, pretend you don't know that you're responsible for the ring, and fake an illness. Okay, so it looks like you can kind of see the shift in the quality of the options that are generated, which we might expect if you're kind of reasonably foraging through the option space. You can also flatten that just to make it easier to think about. So the way I've done this is just, I took the average of the immorality, abnormality, and probability judgments. So basically higher is going to be worse. So the very best options would be like a score of 0 in this case. And then you can think about how that score changes sort of across the number of generation. That's the pattern that you see overall. It's true independently for immorality, for morality, normality, and probability. We just took the average of them because it ended up being sort of the easiest way to combine them. Okay, so if you now think, okay, suppose that's right. You have this ability to think about sort of the value of the options, and you have this representation of the space of the options. Then it seems that you should also have something like a representation of like the overall likely value of the options in that space. You should have this kind of summary statistic-like idea, or the distribution of the value of the options in that space. You should have something like that. And you could think about representing that in something like a distributional form. So say you take this context with Daniel as the ring bearer, and he left the ring in the taxi. You can think about the set of options that people thought of in that context, and then you can think about the value of them. So this is just the empirical data, and the idea is maybe people have a representation that's kind of like this. They can represent, how good are the things, the likely things that Daniel could do in this situation. That's what it looks like in the Daniel context. If you go to a different context, like the Heinz context, the distribution will look a little bit different. Like it's going to vary from context to context. We use 18 scenarios in this study, and if you look at the sort of the distribution across all of them, that's the distribution that you see. So that should be something like your prior, at least for the kinds of scenarios we used. Okay, so now what we want to know is, if people have this kind of representation, can we use it to predict people's had-to judgments? That's the next step. So can we show that at least for one kind of high-level judgment, like whether or not someone had to do something, we can predict it using that kind of summary statistic. We use judgments of force sort of like as this canonical example of like the case where the alternatives really matters. So it was just kind of the easiest way where you're sort of not explicitly saying like what's possible, but it's a high-level judgment that just in a straightforward, obvious way depends on alternative possibilities. And so that's why we started there. So the way that we did this is we go back to these kind of contexts where we got samples from what people thought Daniel could do. And then we took new participants, and then we just told them that Daniel decided to do some particular action. So for each scenario, we came up with 6 different actions that the agent could do. In the case of Daniel, it was call the taxi company, borrow their mom's wedding ring, tell his sister as soon as possible, blame it on the maid of honor, run away, or steal someone else's ring. And we chose those so that they kind of vary in the quality of how good of an option they were. So new participants would read a context, they'd see that Daniel decided to do one of those 6 things, and then they would answer the question, how much do you agree that Daniel had to do that particular action that he did, the actual action? So what we want to do now is like think about those actual actions relative to the value of the other options that are in like the possibility space for that context. So let's say that in the case of Daniel, this is kind of all the options that people were able to come up with, previous participants. And then we can think about the 6 actual actions kind of situated within that distribution. So here's where they would fall. So we had other participants rate them on the same dimensions, and blaming it on the maid of honor is about here, stealing the ring is about there, telling his sister is down here. It's just like a good, normal, moral thing to do. Okay, that's the set of actions, all 18 times 6 actions across 18 scenarios, just to give you a sense for like not just one context for all of them. Okay, so now what we want to measure essentially is like how much were there better options in that scenario? Like if you did have this representation, how much did you think like there were many better things to do? So what we can do is like we can think about basically the area under the curve that's better than the actual action that was done. So in this case, we just did it by like sampling. Essentially, we don't sample three actions, but sample like 10,000. Sample sort of 10,000. But that gives you an estimate of basically this space, which is it shouldn't be super like crazy or hard to understand. It's basically like, to what extent do you think there are better things available in that context? It will change depending on 2 things. So one is that, we'll call this thing the modal distance. And it's called modal distance because basically it should align with this intuition that like, someone's like, the sort of most obvious things somehow feel closest in an intuitive way. And the weirder, sort of farther out, worse things feel farther away. And so it's supposed to align roughly with that intuition. So the closer it is, the fewer options there were like more available. And the farther away it is, like you're like, there has to be other things that were better than that. Like, come on. So that's going to vary based on 2 things. One is the actual action, because if the actual action is just a lot better, modal distance is going to be smaller. And the other is that it's going to vary dependent on the context. So if there's a context in which there were just a ton of good options, then even for an option that's pretty good, there's going to be a relatively high modal distance, because there's going to be a lot of better alternatives. For an option that has very few good options, like the modal distance is always going to be smaller. So contextual modal distance is a function of both the value of the actual action and the value of alternative options. Okay, so that's the key thing we're going to use, and we're going to ask, can we use it to predict these had-to judgments? So what we can do is go back to this, say, in the context of Daniel. Here are the 6 actions that Daniel did in various cases. And then here's the modal distance for those actions. And what we want to know is, can we predict using that modal distance participants' had-to judgments? So the more you think there are better options available, the less you should think Daniel is forced. So you should see basically a negative relationship between the two. In the context of the 6 actions of Daniel, that's what you see. You see this nice sort of negative relationship. You can look at other cases. So this is the Heinz case we talked about. This is another case with a person on a ship. You can see what it looks like in that case. If you look across all 18 contexts, that's the relationship you see. So I think this is I was surprised that it worked as well as it did. This is a relatively simple way of thinking about an actual action relative to a set of alternatives in a context. We're getting it 0.9 our correlation between the two. The had-to judgment, which feels like this very complicated high-level thing, and this modal distance score that we were able to generate. Okay, so this is a little bit of evidence that if you can measure that contextual modal space, at least in one case, had-to judgments, you can predict how people are going to make that high-level judgment. So it looks like that probably that representation, at least plausibly, is recruited by high-level cognition. It also is, as we talked about, norms play a big role in that. Okay, so those are the first 2 points. All right, just since it's warm in here, are there any questions? Let's take a quick reset. Yeah.
I'm very interested in, obviously a lot of the responses are things that are highly probable and I guess good, right? And then there's this downward slope. At the very end, there's an uptake.
Totally.
So it seems like people are reaching, when I exhaust the good options, I just immediately reach for the wacky, weird, bad things.
Yeah, the thing is that the number of wacky, weird, bad things there are to do is indefinitely large. So I don't think what's happening is just that I kind of run through the quick good ones, the obvious ones, and then generate a particularly bad one. I think probably even these bad ones have some features that make them better than even worse ones. So a lot of these are things in the case of Daniel, stealing someone else's ring, or lying to get out of the situation, or blaming it on someone else. But those are things that, at least from the agent's perspective, would have particularly good qualities about them. They might be better in the immediate sense. So I suspect what's happening is, in some ways, this is kind of an incomplete sort of estimation of the value of those options, at least from the agent's perspective. There's something that makes these okay to think about in that scenario. What you don't think of is things like, Daniel scrounging underneath his chair to find a turtle, to break it in half, killing the turtle, but it happens to have a ring in it or something. There's the tons of bad, terrible, improbable things you could think of that no one ever generates, right? Usually there's something about things that you generate. But you're right that this sort of bump happens in a lot of cases, which suggests that there's some structure to the possibilities, where oftentimes things that make something bad are also make it a good thing for us to do.
So this is what I was wondering, is are there competing constraints here?
Yeah.
Make those two ends of the spectrum kind of attractive for different reasons.
Yeah, I think that's probably right. And especially if you think maybe people are somewhat likely to do bad things when they run out of other options as a way of getting through the situation, like stealing. Yeah?
Are your agents getting feedback? So if they do, then do you think the curve will be different?
They get no feedback. You mean feedback in the sense of
Or good or bad choices?
Yeah, I don't know how that would affect this particular case. I suspect the structure of the feedback would change the options that they're willing to consider, basically trying to get them to think of ones that give them better feedback. In other studies that I'm not going to talk about, one thing we've tried to do is come up with, in these cases, people come to these studies with a lifetime of experience with these kinds of options and similar situations in some way or another. So we don't have a lot of control over what they bring to the study. In other cases, what we've done is we've come up with totally novel situations they've never been in with feeding weird monsters various kinds of food. And then we have a lot of control over their experience with those options. And then we can show basically a similar kind of thing, but where we can sort of experimentally control the feedback that they get through their experience.
I like following this, that by the time you make these measurements here, you have said, well, what Daniel actually did was some kind of bad thing.
This distribution, so if you ignore the red stuff, this distribution is just we asked people, what could someone do? And then we gave them back their answer and said, how probable is that, how moral is that, and how normal is that? That's all, and we average them. That's just this distribution.
Okay.
We give other participants, we ask the participants to answer they had to judgment, never generate alternatives in these studies. We give other participants, say, like, suppose that Daniel were to call a taxi. How normal is that? How moral? How probable? So we can situate call a taxi relative to the other options. And then we use these two pieces to predict other participants had to judgments. So it's a very like a cross-participant item level analysis.
It looks like there's a lot of people coming up with these sort of, criminal activities and things like this. Did you? There wasn't anything that would bias that really spontaneously.
No, and it varies across scenarios. So some scenarios I think really invite a like stealing, doing lying, bad things, and other scenarios don't so much. Yeah, but we did nothing to bias them to do that. And then the other key thing to remember is like for this modal distance measure, everything that's better or worse than that option doesn't count. Right? So it's really just a measure of how many better things there were. So in some ways, these play the least predictive role for us. Yeah, in the back.
So I'm just curious as to the. It seems like what's at the far end of your tail is stuff that is not moral but still highly possible. And so I'm just curious as to whether you can tell me whether there's stuff within that distribution that seems like it rates poorly because it's highly probable. Because the sort of the examples of possible things we could do as we were talking about.
Yeah.
It still seems like they all rated pretty high in possibility. Like fake heart attack, I think, is a pretty generic way of describing fake sum X such that X is likely to get you out of Y.
Yeah. In these slides, I think I do not have the relevant the data. So can I draw on this thing? Not really.
There are markers.
Are-
You can draw on that side.
You can
Try.
Is this acceptable?
Yeah.
I'm going to make up some data, but the pattern is going to be true. The actual particular lines will be false. So this is generation number, say 1 through 5. And then I'm going to just use, say, like this color for morality, and this color for normality, and this color for probability. The basic pattern that you see is that across all three, you see a decrease. Morality is the highest line. And decrease is slightly faster than the others. Normality is kind of like in the middle, and probability is something like that. So what this means is there's nothing like special about probability. If anything, morality is like sort of the hardest constraint, and that people are relatively unwilling to think of actions they would rate as immoral, where people are somewhat more willing to generate actions they think of as improbable. But for every one of them, by the time you get to the fifth option you generate, it's very likely to be worse on all three dimensions than the first.
So if I could follow up with that, I just think that it seems like probability intuitively might be a harder constraint than that. So if you can imagine a hypermoral situation where not only do I tell my sister, but then I find the ring because I call the taxi company in
Like
relevant ways
some sort of
that I
supererogatory,
go beyond,
yeah.
right? So I do this supererogatory thing.
Yeah.
And that seems like it should rate really high in morality, but
Yeah.
it seems like a deeply improbable situation,
Yeah.
given that tracking down that taxi in time for a wedding that you
Yeah.
are currently at, that you
Yeah.
need to ring for in 5 minutes, super improbable.
Yeah. Right. So I think probably by the time, so all of these are sort of joint, my sense is all of these are joint constraints that are, and so that feature may be really high in morality, but it's so improbable that it's relatively downweighted. That's my guess about what's happening. So you're sort of looking for these things that are sort of high on all dimensions to the extent you can find them. Yeah.
Actually, I have a related question because I'm trying to wrap my head around normality and what it means. So these three dimensions, are they fully separable?
So what normality, theories of normality suggest that like they combine features of morality and probability. So you can be abnormal because you did something bad, even if it was very likely to do. So like you might say there's something like not normal about cheating on your taxes, even though a lot of people cheat on their taxes. You could also think of like an action that was improbable but perfectly moral. So morality and probability are supposed to be sort of independent contributors to normality. We do find that relationship here, so they're sort of both partially predictive of normality ratings. The other thing you can ask is like, so does that mean you should just use normality and forget about the other two? Or you should really just ignore, also maybe there's like a general trend where people tend not to do unmoral things. So just maybe it's all really probability and just forget about morality. So one of the things we did is we created these modal distance scores. We created 4 of them essentially. So we created the one we used, this average. We created a probability-based one, a normality-based one, and a morality-based one. And you can enter them all in a model where you're trying to predict hedging judgments. And you can sort of selectively drop some, like by legioning the model in a sense. And then you can ask, like, do they sort of each independently account for some variance? So if you just enter these 3 in the model, each one, if you drop, reduces your predictive power. So they all are independently contributing in some way or another. Does that help answer that?
Yeah.
But they're highly correlated, right? So you can,
I was wondering if normality is just like a function of morality and probability.
Yeah.
Because I'm showing a thing like what square third.
we find some evidence for that, but it doesn't seem to be exhaustive, essentially. Like, yeah.
So, do you see the same pattern across situations that might be considered like taboo trade-offs, for instance?
Mm-hmm.
So, where what's happening morally is as a value that's really sacred that's being violated?
Yeah, the taboo trade-off stuff is super interesting. Where it's like you're kind of like unwilling to even consider certain options. I was interested in that stuff in my postdoc, and I made 0 progress on it. I think the short answer is that in all of our cases, we don't really have obvious taboo trade-off cases where it's like money for someone's life or something like that. There are always cases where the agent faces a problem. Probably the things you should be doing or like don't necessarily require you like killing somebody. Like there are very few cases where, or no cases where that would really be a thought that should come to mind.
Yeah, do you have a sense that this pattern might continue in those situations? Because I'm kind of thinking of like if an option to resolve a taboo trade-off is an instrumental use kind of thing, where like it has some benefit to the perceiver. That the pattern might look a little bit different as far as like probability might not matter at all.
Yeah, that's interesting. If I had to guess, I would predict that this pattern will generally extend. It'd be interesting to try to come up with scenarios to see if that's right. But that's my sense is I thought that this wasn't going to be as stable as it was, and that I just find this pattern every time I look, no matter which way I look at, like try to generate it. And so my sense is that just would probably be true even in those cases. I mean, I do think there's something that feels a little bit special about the taboo trade-off cases, but because you're generating multiple options in these cases, my sense is, if the taboo trade-off thing was really meant that you didn't ever consider this particular option, like that would just change the sort of meaning of these judgments. Maybe like by excluding that option, every option is sort of higher morally from 1 through 5, but it's still just going to be this general pattern. That's my guess. All right, last question, and then hopefully we're all awake again. Yeah.
I had a question about the reaction time data.
Yeah.
I was specifically curious if it sounded like people take longer and longer as they keep generating.
Yeah.
I was curious if people thinking about the explore exploit kind of model.
Yeah.
If they enter a sort of new like resource patch of options, do you see any sort of?
Oh, cool. Yeah. Yeah. There are 2 things to say. So one is if you look at RT across option generations, in this case we got them to generate a bunch of options. The pattern is actually, so you're relatively fast for about the first 3, and you don't increase that much. And then there's a kind of a bump, and then there's like a long sort of linear increase. So it looks to me like probably there's some switch between the kinds of systems we're using, somewhere between 3 and 4 options. Like there's some immediate setup that comes to mind. I don't know that this is right, but that's my intuition. There's this other super interesting thing where in the other foraging work on like memory foraging, so thinking of like zoo animals, basically you're faster to, if you think of like tiger, you're faster to think of lion. So if you're in a patch, like you can kind of think of relevant things faster. We find the opposite pattern, if anything. So if you first think of like call a taxi, and then the next thing you say is like call an Uber, that's actually a longer time period. And my sense is that what's happening is, again, just guessing here, but my sense is that like you were trying to think of a better patch to jump to, and you basically couldn't, and so you went back to something more local. Yeah.
Yeah, so I've been sitting here all along thinking about exactly that. So I was trying to see, so Chung Zhang is not here, and neither is anybody from her lab. So they do this stuff on, I'm going to completely misrepresent her research.
Yeah.
They do this stuff on collaborative recall. And they first have people recall stuff alone.
Yeah.
And then they have people recall stuff with other people. And there was like this deficit that when you recall with other people, you actually get worse because you don't explore the space. But you're also pretty bad by yourself because you don't explore the space. Now that's having just studied some list that you're about to recall.
Yeah.
And so what they're doing is they're developing an algorithm that takes a space where you have not yet explored, and they give you cues from that space in order to encourage you to go in, and that actually improves performance.
Yeah.
So when Mimi said, do you give people feedback, I thought she meant like, do you encourage them in when you were doing that foraging thing? Do you encourage them to go into a space that they have not tried?
Yeah.
Because I was having that same intuition, like if I say call a taxi, then I've sort of depleted that as an option. Like if I was recalling things, I might say things that were very similar, but if I was trying to come up with solutions, I wouldn't want to give another one that was very similar. Like I needed to be creative in some way. But people, I mean, people are not doing episodic recall here because you're not going to let them study anything, but they're in some sense doing semantic recall, like trying to recall from the possible space of things that you can do.
Yeah.
And they can't figure out how to explore into a new
Yeah. Yeah, I think that's, I think that roughly aligns with the way that I've been thinking about this stuff. I think maybe it's a pragmatic constraint, I'm not totally sure, but basically when you've generated an option that feels like in this area, you should try to generate a different kind of option when I ask you what else someone could do. Or generate.
It also seemed like from that walk that people were somewhat bored. I mean, so there were some jumps back and forth, but people were nowhere near exploring that big color of space that you have.
That's right, yeah.
And so, so I guess the question is sort of about like the feedback, like giving them cues into another space to explore more options.
Yeah, we really haven't done much about like trying to increase exploration by giving them cues to the space. This has really just been like, in some sense, we got into this puzzle just because we were trying to find a measurement of like that implicit set of possibilities. We weren't interested in like forcing them to shift that. One of the things we've been doing recently is giving them sets of options that other people generated or an LLM generated, and then ask, can you sort of shift their representation of that space by doing that? So maybe we can chat a little bit about that at the end, but yeah.
Well, I would guess that this kind of and with reaction test is probably quite a general thing. Usually in line with a task, I forget the name of the task is, but one of the tasks designed a test from front-row patients, and did a nice job separating them from in that break group. Also what's the same with preschoolers. So it's just simply asking names of all the animals that you can think of. And you get the first set of animals come up fast, and then it's harder and harder.
Yeah, I think we actually have data on generating a zoo animal, and we have RT data, and it'd be interesting to see the extent to which this pattern holds. We can talk about that thing at the end more. I mean, I've been thinking a lot about like why. One idea I've had is that if you think about there's an information theoretic way of thinking about how you're representing the set of possibilities that suggests the more you generate, the more there should be kind of competition between them, which should make it harder to generate new ones. And that's another, like with a colleague, I've been trying to explore that possibility of that helping explain a bunch of general features. So anyway, okay, so I want to talk about trying to use that same representation and just show, hopefully relatively quickly, that you can use it not only to predict type 2 judgments, but also a range of high-level judgments. So it's kind of general purpose. So here's one way we tried to do decision making. So for most decisions you make in life, like they're often open-ended, like what to have for lunch. Like you can't solve that problem by selecting something from a list unless you've like someone's given you a list. Generally, you have to like generate the options you're choosing between. So this sort of set of options really matters for a lot of all open-ended decision making. And we thought, okay, so if we give people these same kinds of scenarios, and then we just ask them, what would you do in this scenario? That is, maybe we could take models of sort of open-ended decision making and then use our sort of space of options to think about what the sort of options they could come up with were, and predict sort of on aggregate what kinds of decisions people are going to make across those scenarios. So just to give you a sense like of the model I'm going to draw on was one that I helped develop with Fiery Cushman and Adam Morris. The thought was if say you're choosing what to have for lunch, there's a set of options that you could think of, so everything from like pizza to fish to pasta to tacos, et cetera, and there's really a huge list of those. We solve that problem all the time, and we have to reason over a small subset of that space. And the basic proposal we had was that we use estimates of past value of the options to determine how likely we are to sample new things. We did a bunch of work to show this in very controlled ways. I'm going to take this as a sort of general sketch of a proposal and then think, can you apply it to our very open-ended scenarios? Like in our cases, we always had a very definite list. We knew the value of every single option. In this case, we don't. We don't have a complete list of every possibility. But we can kind of do the same thing. So the idea is maybe we have options that people are generate in general. So like telling the bride, calling a taxi, lying, panicking. We can think of if people are asked to make a decision, they have to come up with some subset of things they're deciding between and then choose one of them. And so we can take that general model and then apply it to our case. The basic way you do it is we have simulated 1,000 agents using that two-stage decision-making model. And the way that worked is, so each artificial agent sampled a small set of options out of all the ones that participants generated. And we know we use the participant who generated that option, their value estimates. And then they select, of the set that they consider, they just select the very best one. Okay, so we can do that 1,000 for 10,000 different agents, and then we can sort of average across them. And now think for each category of action, how likely were people to choose that, or how many artificial agents chose that? And then we can basically collect decision-making data from new participants, and then just ask like to what extent do they line up. So across like kinds of actions that could be done, can we predict what new participants will decide to do in these scenarios? And here's what that data looks like. You do a relatively decent job of predicting. Okay, so that was one little piece where the idea is, okay, we've got this general way of measuring contextual middle spaces. If we know decision-making relies on something about representing possibilities, we can kind of slot that in the right way with a basic model of decision-making and then predict decision-making in the same scenarios. Okay, so now can we do also causal judgments? The kind of causal judgment we worked on is what's called a judgment of causal selection. So like if I asked you something like, say there's a forest fire that occurred, and I say, what caused the forest fire? Then you can select something, some preceding event as the cause of the forest fire. People do this all the time. You might say, oh, it was the gender reveal party gone wrong. That is, of course, not the only necessary event for a forest fire, right? There had to be probably drought. There probably had to be oxygen in the air. There probably had to be like fodder to burn, right? Those are all other contributing things that were necessary. But people tend to select some particular thing as the cause. So if you want to, so the idea is we can take models of decision making and then think about how they involve possibilities, use our contextual modal space, and try to predict people's causal judgments. So to walk you through that, we took these models, some of which I've worked on, some of which I haven't. But all these models basically emphasize two key components. So one is to say that, say the gender reveal party caused the forest fire. Part of what you have to do is think that there were other things that could have happened other than the gender reveal party. Like maybe you could have not had a gender reveal party, for instance. And then you have to think that the outcome would have been different if the gender reveal party hadn't happened. So two things are important: there being alternative actions, and that if the alternatives that had happened instead, the outcome would have differed. So we're going to take those two pieces and combine it with our thing, and then we're going to see if we can predict causal judgments. So sort of pragmatically speaking, what we do is we go back to the same scenarios, like Daniel and the ring bearer. We say Daniel decides to do one of the actions, again, And now there's some downstream consequence. So let's say that Daniel decides to blame it on the maid of honor. And then when his sister finds out, when the ring is missing, she's disappointed and decides to cancel the wedding. So that's the downstream consequence. And now you can think about whether or not Daniel had to cause, or Daniel caused the wedding to be canceled in this case. So there are two judgments that they made. One is this causal judgment, and the other was this counterfactual necessity thing that I talked about that's important from these models. So the other participants rated the agreement with if Daniel hadn't decided to say, blame it on the maid of honor, the wedding wouldn't have been canceled. So we're going to take those two pieces. Okay, so we go back to modal distance, the same thing we've been measuring for each actual action. And then we think, oh, so that's going to be a measure of the extent to which there are better alternative actions that could have been done. So blame the maid of honor, not that good. There are better things to do, sort of higher modal distance. And then we want to know, like, did people think that if you hadn't blamed the maid of honor, the outcome wouldn't have occurred? So the wedding wouldn't have been canceled. So we take those two, we multiply them. So this is the counterfactual necessity judgment in each of those cases. And then we get this score, which is going to be what we call necessity strength. So this is a representation of both were there better alternatives, and if you had done them instead, would the outcome not have occurred? And now we're going to use that to predict causal judgments. That's the case, that's what it looks like for Daniel. Here's the Heinz scenario. Here's another scenario with Ahmed, who's a ship captain. And we're going to use those necessity strength judgments to predict causal judgments. So that's what it looks like across the three. And the basic intuition here should be, the more that you think there were better alternatives, and if you had done them instead, the outcome would have been different, the more you should think the agent caused the outcome, essentially. So it should be this positive sort of linear relationship between necessity strength and causation. If you look across all the items that we used across all the scenarios, that's the relationship you see. It's about 0.75 correlation, so relatively decent. You can do, I won't make you go through all the details, but you can also do the same thing with moral judgments. So if you ask, should Daniel be blamed for the wedding being canceled, for instance, you can predict that, and blame also requires alternative possibilities, alternative actions that could have been done. You can predict moral judgments as well. So the key thing here is like, look, it looks like with this one kind of representation, once I've measured it in a context, I can use it to predict like a whole range of different high-level judgments, from decision-making to had to causation to moral judgments. So it looks like it's general purpose. The idea is that one representation is being recruited by a bunch of different judgments. Okay. Yeah, good.
I have just a quick question. Do you think that their higher ratings in causality is actually causing them to judge it like less moral? Because those two things definitely correlate with each other.
Yeah. So it's hard to blame someone for something if you didn't think they were causally responsible for it. Yeah. So whether or not you should really think of morality as totally independent as the causal thing, that's a reasonable question. The two can come apart. So it's not that they're identical questions. So you can change like, you can have things where a person obviously did cause the outcome, but you think that they didn't know that they were causing it, and so therefore they shouldn't be blamed for it. So you can get variation in one without the other, so I don't think they're identical. So it's not trivial that you could do both.
Okay.
But I agree with you that they're going to be correlated, yeah. Did you have another?
Yeah, so you're saying that the modal distance led to causal attributions to Daniel in this scenario, right?
Higher, so the more you think there are better options available, and you think that doing those would have mattered for the outcome,
Yeah.
the more you think Daniel caused the outcome. Yeah.
Okay, and then if you think about it the other way,
Uh-huh.
right, who are they blaming then if it wasn't Daniel?
Right. So yeah. Well, in some cases, I think you can get an intuition, like in the to not blame Daniel. You might think one thing you could do is blame nobody.
Which people don't usually say.
If you think people are blaming someone, one of the things you realize is that like there is going to be some kind of trade-off between the different agents. So like let's say that Daniel decides to call the taxi company, and now his sister just cancels the wedding.
Yeah.
It feels like Daniel did the very best thing he could do, and like despite that, his sister canceled the wedding. So it seems like if you're gonna like attribute the wedding to a cause, it's probably his sister in this case.
Yeah.
Maybe you would also blame her for the wedding being canceled. I don't know. But yeah, so but the key here is not. It's really, at least what I'm measuring is causal for Daniel, not so much his sister.
Sure.
But it looks like the fact that you don't think there was a better thing for Daniel to do makes you think like he wasn't really the cause. Like what else could he have done? Yeah.
Are we restricting our set of alternatives here to like post losing the ring, just like the things you can do afterwards? Because I'm getting anything interference from you could have not lost it in the first place. Like you had better chance, right?
Yeah, I mean the thing that they do, right, is they still generate these. I don't know where they still are given the scenario and just ask what could Daniel do, given that context. And now nothing stopped a participant from saying, well, he could have not lost the ring. And so if someone wrote that, it is in there, and they would judge it on the probability of that happening, the normality and morality of that happening. So it could be that people did that but put it at 0 probability because, in fact, it didn't happen, which would make it sort of low value. So it's possible that's what happened, but we didn't control participants very much. We just totally let them do what they're going to do. Yes.
I'm just trying to understand the scenario. So
Yeah.
the sister cancels the wedding because the ring is missing. Right.
When his sister finds out the ring is missing, she is disappointed and decides to cancel the wedding.
So it's sort of interesting, making these judgments, but what Daniel decided to do is completely causally relevant to the reason the sister is canceling the wedding. Right? So whatever people are doing, they're using the word cause to talk about some stuff that, at least from an objective point of view, is clearly causally relevant. So, like, I'm wondering if we fed this back to subjects, would they dig in and say, yes, it was the borrowing the ring that really, because I just wonder, like, what?
Yeah.
I'm just wondering, are they thinking that the sister is canceling the wedding and is disappointed in part because of how Daniel handled the situation? Or are they thinking just the face value? Oh, yeah. I mean, the ring being lost, that wasn't going to bring about the canceling of the wedding.
Yeah.
It was somehow him blaming it on the maid of honor. And so I'm just trying to...
Yeah. My sense is that it must be the latter, given that the variation of what Daniel did matters somewhat to causal judgments. And, I mean, we don't strictly say she decides to cancel the wedding only because she's disappointed about the ring being lost. I mean, clearly that's a factor. And then the thought is, maybe there are other factors like Daniel's behavior. You know, if your brother decides to steal someone else's ring in the middle of the wedding, like maybe you do think that would be relevant for canceling your wedding. I don't know.
If one thinks that you actually cannot get married without a ring, felicitous, and relevant as you're disappointed.
Oh, you can get married without a ring.
Well, I kind of feel...
You can get married with a signature.
I hereby pronounce you man and wife. Well, I'm not authorized to do that because I didn't take my $10
online training.
Course, but where I come from, or when I come from, you have to have a ring to get married. That was it. The ceremony couldn't finish, and so she's infelicitous, so she's causally constrained by not having a ring.
Right. So if we were unfortunate enough to have you in our study, I think that what you should be judging is that Daniel was 0 causal across all these, right? Because the or maximally causal, one of the two. But there shouldn't be variation based on what Daniel does because there's no ring.
Yeah, I mean, because the causality in my belief about these things, getting married, is that if he lost the ring, so that would be the causation of there being no ring, and then she can't get married.
So you would just say he's maximally causal in every case.
Yeah, he's maximally causal, but for example, fact that he decides to call a taxi company doesn't change the causality of it, if that
Right.
doesn't work.
Right. So yeah, that's what I was saying. If we were unfortunate enough to have you on our study, then you would judge every one of these the same, and so we wouldn't be able to predict variation in them essentially. So I agree. I mean, I can see how you have.
Particular end of where she cancels the wedding.
Yeah.
I mean, actually, the absence of the ring cancels the wedding. So.
Right. So maybe you'd say 0, but then you would still say 0 for all of them.
So, I mean, Daniel decided to call the taxi company might sort of, unblock his copy of just a little bit because, well, he didn't just sit around and say, right?
Yeah.
But it wouldn't change causal questions.
Right. Well, I guess people disagree with you on the causal question. At least for this scenario. I mean, we use 18 scenarios, so not all of them involve weddings and rings.
Then I wonder whether they understood causal and moral.
Yeah, you can't.
It's a weird thing.
Yeah.
I'm realizing as I'm thinking about this scenario that relevant for me, I mean, it seems even more relevant for me as your counterfactual question if he had done otherwise to the outcome of anything.
Yeah.
And that's not so much about the specific decision made, but the alternative decisions that could have been made.
Yeah.
And I'm thinking about, well, if I call the taxi company, there's a chance that the ring could be recovered if I fake a heart attack.
Right.
Right?
Yeah.
And so I'm wondering if, in thinking about the modal distance scores don't reflect the likelihood of recovering the rate. And
Yeah.
we have a
Yeah.
But it's different with this one. Is that something that you have measured for each of these choices as well? Like, if you thought about that as being a factor into people's causal decisions.
The,
as well. So
the
not
counterfactual
only-
necessity?
Yeah, well, so not only the modal distance, which is a
Yeah.
reflection of the morality, normality, and probability of the alternatives, but also the likelihood of the success of those alternatives.
Yeah, so the way that we do it is this general question, which is like going to capture the sort of, so we say if Daniel hadn't decided to do the actual action, the wedding wouldn't have been canceled.
But that doesn't get us at, for any of the other alternatives, whether they...
A different way of doing it would be like, what's the probability of the wedding not being canceled if Daniel had done this particular alternative? But they're going to, so, and then you can take that whole set. The thought that I had, rather than, maybe I was lazy, but my thought was that whole set, once you do it, should be deeply related to this question. Because if the relevant alternatives are the relevant alternatives, then you would do something else instead. So if you hadn't done this, you would have done something else. And then the question is, marginalizing across them, what's the probability of that? That was the idea. I actually had the thought to do it your exact way, and then I was like, that's a lot of data to get. I wonder if I could do it more cheaply. But yeah.
So it seems that, I think we're sort of circling around something very complex happening here with respect to what a good resolution for these scenarios might be. And when we think about Daniel's point of view with 4 kinds, there is something specific, I guess, that they want. In Daniel's case, I guess he just wants to avoid blame. But then upstream of that, there's, well, you want the ring back. You want the ring to be present.
Yeah.
And so some of the actions he takes, or could take, some of the set of alternatives is solving one problem, getting the ring back. Some of them solving a different problem of just avoiding blame.
Yeah.
And I guess it's those feel like very different kinds of things. And each scenario is going to be different with what those are.
Yeah, each scenario will be a little bit different. I mean, like in the Heinz case, basically his wife, her health gets worse. And so it's whether or not Daniel caused her health to get worse, or whether or not he should be blamed for her health getting worse. And then the actual actions are things like committing credit card fraud or asking a pharmacy for a discount. Yeah.
Disappointment is a really important mitigating factor in the causal role of the wedding being canceled.
Yeah.
So the ring being lost is going to give you some level of disappointment, which is going to be that Daniel's intervention would be able to modulate that disappointment. Essentially, it would be large enough to, place wedding canceling, or minimal enough that you can proceed on merely a signature.
Yeah.
And so I would take it that the thing that modally is super useful is all of Daniel's different actions are going to modulate that disappointment to varying degrees. So honesty presumably would some disappointment, but way less disappointment than, oh my God, I got a ring and my brother died.
Yeah. Yeah. Yeah, I mean, I didn't do like sort of like the diagram for every single scenario. I think plausibly a lot of the things that Daniel could do probably would go through or be, conditioned, like basically the way that they would impact the outcome is through his sister. It's because she's the one canceling the wedding in this particular case. In other cases, it won't have that exact structure, but yeah, I think that's plausible in this one. I mean, I have to say I was kind of surprised that it worked as well as it did. Given the complexity of this one scenario, the more you dig into it, the fact that we were able to predict variance at all was surprising. So it looked like, I mean, maybe there's a lot more structure to be uncovered, but minimally we seem to have gotten somewhere in predicting these judgments. Okay, so let's see, where were we? Okay, so far I tried to say we can measure this thing. Here's some interesting ways to think about how people are representing this possibilities in a context. Maybe they are recruited by high-level cognition and generally recruited by high-level cognition. And then the two other pieces I thought it'd be fun to get your thoughts on are, one is that they seem to be flexible and context sensitive. So like, one way that I've tried to show that is showing that the possibilities you generate are affected by other people's knowledge. So what we did was we took the original context, say of like Brad. We used the 18 context again, but we take one where it's like the case with Brad, who in this case knows that there's a town 5 miles away from him, and we create a variation of that context where he's just ignorant of the fact that that town is 5 miles away from him. So he incorrectly believes that they're nowhere near civilization, and then unbeknownst to Brad, they're 5 miles from an inhabited town. And the idea is, okay, so that's just changing this one small piece of the context. But if these representation of the possibilities are really context sensitive, that should shift the possibilities that come to mind. Like maybe in this case, you should be less likely to think of like him trying to walk to that town. Maybe in this case, you should really think of that possibility of him trying to walk to that town. And if you're not thinking of that possibility, what are the alternatives that you're thinking of instead? Because they're still generating the same number of options in these cases. So that is that you can sort of shift those two spaces. And then if we're right that say like had to judgments depend on the contextually dependent modal space, then you should shift your had to judgments sort of correspondingly. So we wanted to see if that would work. The way we did this was exactly what we did before. So we took new participants, we gave them the knowledge or ignorance case, they generated options, they rated them as before. We got new participants, they made had to judgments of 6 actual actions. And then now you can basically get to this way of thinking about it. So we have the, this is the Brad scenario where he's like lost out in the wilderness. Then these are the 2 different modal distance scores for 2 different actions. So this one is stealing food or water. And this one is searching for a water source. And the basic intuition, what you should get from this is like, look, the sort of modal distance is not identical across these. It's going to vary in a bunch of different ways. But that's exactly the variance we'd want. And we want to know, can you use that variance basically to predict the force judgments in these 2 cases? Because if you can, then it looks like, look, that representation really is context sensitive. It really just depends on the small features, which, if that's right, I think it points to a super interesting fact which we can talk about. So the way that we sort of statistically show this is say you start with the cases where people made had to judgments in the knowledge context. So Daniel knew about the town. Say he decided to play hopscotch with his 5 friends. Did he have to do that? And then you're going to try to predict that had to judgment for each actual action with either the modal distance score you got from the knowledge context, that same context, and at the same time we're going to predict it with the modal distance from the ignorance context. So these 2 are going to be correlated. But we're going to build a model where you have both of them, and then you're going to ask, does taking one of these out make the model worse? So is there some kind of special variance that it's able to account for? And if that's right, then it looks like that unique variance means it's like probably better predicted by one or the other. So you can sort of selectively lesion either the ignorance modal distance or the knowledge modal distance. The short version is, if you just look at this, so these are chi-square values, but the key thing is, like, if you want to predict had to judgments in the ignorance cases, you do a lot better when you're using the ignorance modal distance score. And if you want to predict had-to judgments in the knowledge cases, you do a lot better by using the knowledge thing. That's what's accounting for the unique variance. And once you have that, you don't really need the other ones. They don't do much extra work. So it looks like there is this context sensitivity. Yeah.
Were the participants controlled for knowing or not knowing hiking in Canada?
No. Yeah, we had a bunch of random scenarios, and we didn't control participants. So these are people online, just prolific.
It'd be nice to see like how they would actually interpret those subtle differences.
Yeah. That's an interesting point. I mean, in a way, the whole approach, everything I've shown you today is like an item level analysis. So there's this enormous individual variation that we average over in every single case, and we're always just predicting like averages for an action in a scenario or something. Like averages for the modal distance, basically taking all participants who saw that, think of all their options, thinking of judgment relative to that set. So everything is done at this super meta level, which means there's probably a bunch of variance that would be useful to explain that we're just ignoring. Okay, so why do I think that flexibility is interesting? Okay, the general thought is, look, normally when you have a lot of flexibility in a system, that means that it's often an effortful system. Like if you think of language and how we describe things, an incredibly flexible system, that requires some compositionality, which often requires a lot of like explicit reasoning and effortfulness. It looks like this is a case where, if I'm right that these things are really like kind of implicitly represented, like you don't have to think about the alternatives, it's interesting that you would get that flexibility. Like it would be a system that is effortless in some sense or another, but is really dependent on small features of the context. So I think just points to a really interesting aspect of our minds. Then I think there's this important question, which in part touches on this individual differences thing, which is like, I've been the whole time arguing that these are like distributional representations, or you have this sense of the set of options. And is that really right? Or is there a better way to think about it, which is like, for each individual participant, that participant just in fact did think of like 5 options, and then they just made their judgment relative to those 5 options that they thought of. And then all you're doing is just averaging across everybody. And then it looks like you get this very summary-like thing, but that's just because each participant just did think of the particular options that they thought of. So I wanted to try a test for whether or not that was a better way of thinking about it. Does that the 2 things make sense? Okay. So in the last little bit, I'm going to talk about that. So just to give you a sense, like, if you're, let's say you're asked this is the Daniel scenario with the ring. So let's say you're trying to make the had-to judgment, and you want to know, like, did Daniel have to do that? Well, one possibility is you use basically sampling. So you generate a set of options that Daniel could do. So let's say you come up with, like, recheck his pockets, hand his sister's own ring, pretend he has it until the last minute, or panic and alert everyone. Those are the 4, you're a participant answering the had-to question. Those are the 4 options that you thought of. We could capture that fact by thinking like, okay, well, what are the values that you represent for those? And then thinking about those values relative to the actual action that was done. So this is like an individual level way of thinking about how you might calculate whether or not there are better alternatives. And you could create a little summary statistic, which is like, you can think about it instead of modal distance, it's like sample distance. Like, to what extent did you think there were better options, and how much better were they than the actual action for each participant? That's one way of doing it, which I think is, sampling has done a lot of work for a lot of people in cognitive science. Like, maybe it would work here too. The other alternative, which is I think the more interesting one, would be, no, what people have, they don't think of any particular options. All they do is they have this general sense for what's the value of options likely in this scenario. And if you use that, then you can just kind of situate the actual action relative to that distribution. And then we just have our sort of standard modal distance score. And so what we're going to do is we're going to take new participants. We're going to tell them, we're going to give them the scenario. We're going to, we counterbalance whether or not they first answer the had-to question. So Daniel does an actual action. And then they can answer, did you agree Daniel had to do that action? And there's counterbalance. So you could either first generate your options, so what could Daniel do, and then make the had-to judgment, or you could first make the had-to judgment and then generate your options. But either way, the same participant now made the had-to judgment, and we have the set of options that they themselves generated. And so what we're going to try to do is predict that participant's had-to judgment with those 2 scores. Either the sample distance, which is like how much better were the exact options that they themselves thought of, or the modal distance score, which is like across all people, to what extent are there better options available. And we can do that with this same kind of like model lesioning approach. So we use both predictors to predict each individual's head-to judgment, and then so interestingly, if you take out the sample distance, so the one based on the particular items that the person thought of, the model does get a little bit worse, suggesting this does some work, but it's actually not a lot worse. Like most of the variance can just be accounted for with this. On the other hand, if you take the modal distance score out, the model gets much, much, much worse. It looks like there's a bunch of variation that this thing can capture that can't be explained by the particular actions that a individual participant thought of. And I actually thought this was, I thought this was particularly interesting because I think it should, like the same participant made this judgment and this judgment. So if I just had to bet, I would have bet that there's going to be a really strong correlation between these two because it's the same participant. This doesn't get to take advantage of any of that variance. But it still actually does a better job overall of predicting participants' had-to judgments. So I took that as a little bit of one interesting piece of evidence that probably the key representation here is one that is sort of a distributional or summary representation rather than just an online sampling of here's the alternative, here's the alternative. Okay, I think that's plenty long. I want to quickly thank, this is Laura Kerfel, who did the knowledge, ignorance stuff. This is Alina Josheva, who's a grad student in my lab, who did a lot of the sort of foraging and options-based stuff at the beginning. And this is Eli Hecht, who was an undergrad who worked in my lab, who did a lot of the sort of domain general or general purpose stuff. Thank you, guys.